The next part of common factoring is common factoring by grouping. Now, in some situations, the common factor can be bigger than just a monomial. The common factor can be a binomial or higher degree polynomial. So we're going to look at the following. Is there anything that in common that can be factored? And if so, factor it. So if I look at this section right here, and I have a plus sign, so this first section is all attached kind of through multiplication. I have a 3x multiplying the 2x take away 1. And then I have a plus sign separating it from the next part, which is a 2 times a 2x minus 1. If you notice, we have something in common. Both of these parts have a 2x minus 1. So that is our common factor. We're going to divide both of these sections, which are separated by this plus sign. We're going to divide out the 2x minus 1. So 2x minus 1 is common. And what I would need to multiply the 2x minus 1 by to get this first section would be the 3x. The 3x is multiplying the 2x minus 1. So we have a 3x. And then we're going to have a plus. And then if I look at the next section, the thing that's multiplying the 2x minus 1 was this 2. So I would need a plus 2. And there's my factored form. Now, if you want to check, if you don't believe me that this works, you could expand and simplify this to put it in standard form. You could expand and simplify this one and put it in standard form. And you should get the same thing. All right, if we look at this next example here, if I look at the first section, which is then separated by the subtract sign, and here's our second section, I notice they both have a 4x plus 1 in common. So we can common factor 4x plus 1 out, and I would need to multiply 4x plus 1 by the 4x to get the first term. And then I'm going to have my takeaway. And then I have a 4x plus 1 already here, but I can't just leave that takeaway hanging. I just want the takeaway one group of 4x plus 1. So I'm going to put a 1 in its place there to hold it. Now again, I could expand and simplify this one, expand and simplify this one, and they should give us the same thing. All right, so those two have already kind of been set up so that you can see what the common factor is, but sometimes the polynomial may have no common factors that are monomials. However, if you try grouping the terms, so for example, two sets of two terms, you can factor something out of each group and end up with the situations above. So we're going to add another step here. So we're going to try common factoring the following polynomials by grouping the terms. Okay, so I've got 4 terms here. I'm going to try 2 sets of 2. If I look at these first 2 terms here, I'm noticing they have a 2 in common. So if I were to pull a 2 out, or take the 2 as my common factor out of that, there's no variable part that's the same. The first one has an x, the second one has a y. There's no common variable part, so I'm going to start my bracket. I would need to multiply 2 by x to get my first term of 2x, and then I have my plus sign, and then I would need to multiply the 2 by the y so that I would end up with my 2y. Okay, so I'm going to stop that one. I'm going to change colors here, and I'm going to look at the next pair. I have a plus x and a plus xy. As far as numbers go, like they both have a 1, so I could do a plus 1 as a common if I want to put the number part there. And then looking at the variable part, this one has an x squared and this one has x. So x is common with that 1, and I would take just x to the 1 because that's the smallest power. And then I need to figure out what do I need to multiply that 1x by to get back to the original. Now note, I didn't take y as part of my common because this one didn't have a y. The x squared doesn't have a y with it, so y is not part of the common factor. All right, if I times a 1x by something and need to get back to the x squared, I would need to multiply it by an x. And then I need a plus sign, so I would have a positive, and then I need a 1xy, and I have a 1x already, I need a plus y here. Now, if you notice, that has cooked this up so that we have an x plus y in both of those pieces. And if I follow my steps as above, my x plus y is common. I can pull that out, x plus y. and I would need to multiply that x plus y by the 2 for the first one, and then plus, and then my x plus y is being multiplied by the 1x, or just x. You can put the 1 there in front of the x if you like, but it is just the x if you want to leave it as the more common way to see it. All right, try the next one. Put me on pause. See if you can figure out what you can pair up there, and then you can check, and I'll go through that one step by step as well. Okay, let's try pairing up the first two here. I'm noticing both are divisible by 3, so I could try pulling out a 3 as part of a common factor. And they both have x. The first one's x squared and the second one is x to the 1, so x to the 1 is the smallest. So that's my common factor. I would need to multiply 3x by an x to make it equal to the 3x squared for the first term. I need a plus sign to get the plus 6. 3 times 2 gives me the 6, and I just need an x to the 1, which is already here, so I don't need an x with that 2. Now looking at the next part, I know that my bracket is going to need to be the same. I need an x plus 2 in that second set of brackets. All right, but what I have here is a minus x and a minus 2, so that means I'm going to need to factor out negative 1 from that. And if you think about that, when you expand this negative 1 through the bracket, you do get a negative x and a minus 2, which is exactly what we had on the line above. Now that cooked that up to have an x plus 2 common to both. We're going to common factor the x plus 2 out. It comes out front. I would need to multiply x plus 2 by a 3x to get that first term. And then I need to multiply x plus 2 by the minus 1 to get the second part of that. All right, so again, you can check your work. If you expand and simplify that, you should get back to what we had here if we had simplified that one. All right, try the next few examples, and again, I will post solutions on the next slide. Okay, this next one's actually a little bit on the tricky side. And I kind of didn't mean to make this example exactly this way, but if you notice, every single term here has at least one power of x to it. The first one has an x to the 1, the second one is an x to the 1, the third one has an x squared, the fourth one has an x squared. X is actually common to both, so this is going to involve a couple types of factoring. I'm going to first common factor x out, and that's going to leave me with a 4y minus 4. Oops, I don't want to end that bracket yet. And then we've got a minus 5xy and a plus 5x. Okay, so this actually has a common factoring first, and then we're going to group for a common factor. So kind of my bad in terms of how I set that question up, but we'll go with it. I'm going to put those first two inside this bracket. The 4 could come out of both of these. These have a common 5x. So let's go to the next line and see what we have. What we're going to do now is just copy that x down front as if, you know, we're not even focusing on that. It goes along for the ride. If I look at those first two terms there, they have a common 4. I would need to multiply by a y minus a 1. And I know my next bracket has to be a y minus 1 because it has to be identical to what I have here. That means a 5 and an x, and a minus has to come with it, a minus 5x, so that I would expand that and get my minus 5xy and a plus 5x. All right, and I can close the square bracket now, and then I have my x out front. It's going along for the ride. My y minus 1 is the common factor, and my other bracket should have a 4 and a minus 5x. And then you wouldn't normally see the extra sets of brackets there. It would probably just be written as x, and then your bracket of y minus 1, and a bracket of 4 minus 5x. And honestly, order does not matter. I could put my y minus 1 second or third as a factor, keep my x here, put this one third and this one second. As long as I keep the order within the bracket the same, like keep it as a y minus 1 and don't try to switch that to a 1 minus y, I can interchange these whole brackets with each other. The order of multiplication doesn't matter. Like 3 times 4 times 5 is the same thing as 4 times 5 times 3 is the same as 5 times 3 times 4, and so on. All right, my next pair, These two I could put together. They have an A in common, and these two could go together. They have a D in common. Or I could choose to try and maybe pair these two up and take a 2 out, and then I would only have a 1 in common of these two. I think I'll stick with my first go and do the side by sides. In the end, it should both work out to be exactly the same. Okay, so A is common to the first two. I'm going to have a B plus a 2C. Out of the second one, the D is common. I'm going to take a plus D, and then I would have a B plus 2C, which is the same as that first bracket. So B plus 2C is common to both parts, and then I would need to pick up an A and a plus D. So hopefully you're getting a little bit quicker at looking at things and finding what's common. I don't see anything common to every single term here, so I'm going to try pairing them up. Let's try that pair and that pair. I think out of the first I could divide by 2, so that's going to equal a 2, but I have no variable parts the same, so that will leave me with an x squared, and then a plus 2 times 3 is the 6 with a y. And if I look at the next pair, I have an x in common, so I would have a plus x, and then I would have a 4 plus 3y. And I've got a problem. My problem is these brackets are not the same, and that's not what needs to happen there. So it's looking like that we are going to have a problem if we try to take pairs side by side here. Okay, so notice that we have this written right here. It's the same as K, but the terms have been written in a separate or in a different order. And I'm wondering, will that work? Let's see. Okay, so part K didn't work out quite so well for us because our brackets weren't the same. So we're reordering these, and in fact, let's try reordering them even differently. We're going to keep this the same here, and what I would like to change is the order of these last two. So you can actually change the order of terms. You can decide to try different pairings, and sometimes that helps. If I pair this first two together, I would have a common of 2x, and I would need to pick up an x to get the 2x squared and a plus 2 to get the 4x. And then out of these two, I think 3 is common as well as y. So if I take a plus 3y out, I would have an x and a plus 2. Okay, so now this is working. So sometimes when we try pairing, the pairings don't always work the way we want them to, and if our brackets end up not being the same, then we've got a bit of a problem and we have to try another path. So that's what we're doing in this part L here. We're going to end up with x plus 2 as our common piece to both of those parts, and we would need to multiply that by a 2x to get the first one and multiply by a plus 3y to get the second one. So there's our factored form for that one. All right, so you've got some questions to work on now. Let me know if you need some help.